Hello? Alright, let's look at the concepts of limits at infinity. Alright, where the cases under the numerator and the denominator is undefined when you directly substitute this into the function. So, but now this is case infinity or infinity. So for this type of cases where this is a polynomial and this is also a polynomial, we look at the denominator. The denominator become our target here. This will be the highest degree, right? The highest degree. So we only use these techniques when this is the case, right? This is the cases. So then you have limits as x approaching negative infinity. We divide by the highest power of the denominator. Means everything we divide by the x power of 2 here, right? So that it's easy for us to evaluate the limits. X squared minus with x over x to the power of 2 minus with 1 over x power of 2. Can you see that? Everything I divide by the highest degree here. Must be from the denominator. So x approaching negative infinity. And we have x over x to the power of 2, which is 1 over x. 1 over x to the power of 2 divided by x squared. X squared, you have 2 minus with x over x squared, 1 over x minus 1 over x to the power of 2, right? As you know that everything that any number divided by a very big number, negative big number or positive big number, this thing will be getting nearer to 0, nearer to 0. So this one also near to 0, nearer to 0. So you will get a 0 divided by 2. The limit of this function here, you are getting a number 0 minus 0 over with 2. So you are getting 0, right? You are getting 0. So actually, this concept limits at infinity is used to determine the horizontal asymptote. Horizontal asymptotes. Alright? So very easy. When you look at here, the limits when x approaching negative infinity, you are getting 0, right? You are getting 0. So this will show you that this, as the x getting very big negative number or very big positive number, this function, the y here, is near to 0. So it means that the horizontal asymptote for this case, you can easily say that y equals to 0 is a horizontal asymptote. So this is an application of limits at infinity. Alright, horizontal asymptotes. Alright, so same thing here also. If you find for limit as x approaching positive infinity, okay, for these cases, so you're getting 2x to the power of 2 minus x negative 1. So you will apply the same method here as infinity minus 1. You're getting infinity. Infinity square. Wow, it's very big number, right? Infinity. So, and these cases, then you have also need to divide by the highest power of the denominator, which you repeat the same thing here. Alright, so you are getting 1 over x minus with 1 over x power of 2 divided by 2 minus 1 over x minus 1 over x power of 2, which all this turn to be 0. Turn to be 0, and we're still getting 0 over 2, which will give you 0, right? You see, negative infinity, positive infinity near to 0. So it means that y equals to 0 is a horizontal asymptote. It's an horizontal asymptote. So this is the way we determine the horizontal asymptotes, where when the limits of at infinity approaching this value will be your horizontal asymptotes. So it will be okay in the later in the subtopics of asymptotes. I will talk more details about the concept of asymptotes. What is the meaning of negative infinity? You're getting 0, right? So why this is your asymptote? Okay, so next we go for another example. Hi, let's continue with these examples. So then you have limits. One is going to limits at infinity. One is approaching the positive infinity. One is approaching the negative infinity. Alright, I put negative infinity for the same function here. What happened to these two function, this function, x squared minus 4x over 2x squared plus 3, when the value of x getting very big and the value of getting very big negative number. So, okay, for this type of cases, when you can imagine that if you substitute infinity here, if you substitute, I always tell my students, when you want to evaluate limits, you must look for what type of cases. It's either case of 0 over 0, this one you use factorization and multiply or conjugate, or it's a case of a number divided by 0, where the answer is always infinity. So, but now in this case, it's a case of infinity over infinity, right? So when a number divided by infinity, so that is always approaching 0, right? This one always approaching infinity, right? So for this type of cases, these cases now where infinity square, infinity over infinity, so is indeterminate form. You cannot ketidak tentuan. You cannot determine what is the outcome. So this type of case, by observing, you cannot determine. So you have to use a technique here. So x squared, the highest degree now will be x squared. So we divide up and down by x to the power of 2. So divide by x to the power of 2. Power of 2 over x power of 2 plus with 3 over x power of 2. This will be your techniques. Alright, techniques for this type of cases here. So then you have limits as x approaching positive infinity. So this one you are getting 1 minus with 4 over x divided by 2 plus with 3 over x to the power of 2. Right? 3 power of 2. So it means that positive infinity. So a number divided by infinity means that a very big number, it becomes very small. Okay, assumed to be 0. Very small, assumed to be 0. So, and this whole thing will turn out to be very near to 1 over 2. It's not exactly 1 over 2, you know, it's near to 1 over 2. That's why we put a limit here. The meaning of limit is tell you that the value of this near to 1 over 2, but it's not 1 over 2. That's why we have limits, we study limits. So, so now we go for negative infinity, the step will be still the same, okay? The technique will be still the same. It still is the case of infinity over infinity, right? Just the negative infinity here. So you will still divide by the highest power from the denominator. So you will still getting 1 minus 4 over x for these cases, 2 plus 3 over x squared. So you're putting infinity, you are still getting approaching 0, and you're still getting 1 over 2, right? So either one, you get 1 over 2. If you limit of a positive infinity or negative infinity, you're getting 1 over 2, which is the limits at infinity. This value will actually represent your horizontal asymptote. Means that y equals to 1 over 2, y equals to 1 over 2 is a horizontal asymptote of this function. Horizontal asymptotes of fx equals to this function. So x squared minus 4x over with 2x squared plus 3. Right? This is the horizontal asymptote. Means when you're sketching a graph, there is a horizontal asymptote here. So there is a horizontal asymptote here. So, alright, hope you understand about how to evaluate this type of limits at infinity. Alright, and I want to tell you that this value here is represent the horizontal asymptotes. Okay, we go for one more examples. Alright, this will be another examples you can try first before you look at my solution. Okay, so now this is a case, you know that infinity, right? X limits at infinity means x at infinity. What happened? So this one, of course, if infinity cube is a very big number, right? So it's the case where infinity divided by infinity, right? But is this 2 divide? What is the, if this one very big number, this one is also a very big number. So this function will tend to approach what is the value, right? The value here will actually the horizontal asymptotes. Okay, you have to understand this. But to evaluate this one, it's very simple. You look at for this type of cases, the technique is you're looking for the highest degree here. Here 1, here 2, here 3. So x power of 3. So everything you divide by x to the power of 3, right? Divide by x to the power of 3. So 3x cubed over x cubed plus 3x over x cubed minus 1 over x cubed divided by 2x cubed over x cubed, 3x squared over x cubed plus with 3x over x cubed. Every single term have to divide by x cubed. So then finally you simplify the term. So everything divide. After you divide x cubed, you're getting 3 plus with 3 over x squared, right? 3 over x squared. So then minus with 1 over x cubed. This one will be 2 minus with x squared and x cubed. You have 3 over x plus with 3 over x to the power of 2, right? X by 3 minus 1 and plus with 1 over x cubed, right? So as you know that the cases where a divided by infinity, a number divided by a very big number. This is a case where the infinity square, wow, very big, right? So a number divided by a very big number approaching 0, approaching 0, approaching 0, approaching 0, 0, approaching 0. This one all very near to 0, become insignificant. So then the whole thing here is approaching 3 over 2. So 3 over 2 will be the value for these limits at infinity for this function here. Same thing for this one, negative infinity is still the case of infinity over infinity. So you divide everything by x cubed. The same thing here, you divide everything by x cubed. You repeat the same step here. So then you're getting something like this one. So you are getting a limit 3 plus 2, 3 over x squared minus 1 over x cubed. I just copy what from and putting here. So 3 over x plus with 3 over x squared plus with 1 over x cubed. And same thing here, if you put infinity here, everything turn to be 0. You are getting 3 over 2 as your value here. So this one can know that, can verify that the y, this is the y value, because that this one is nearer, this is a y, right, your function. So when x is a very big number, the y here getting 3 over 2, nearer to 3 over 2, means that y equals to 3 over 2 is a horizontal asymptote. Alright, horizontal asymptotes. So, but if you evaluate the limits at infinity, this will be the value here. But if the question asks you, what is the horizontal asymptote for this case here? The horizontal asymptote will be 3 over 2. Alright, 3 over 2. So, okay, why? If you have free time, you can try to substitute a value that are very big. You can choose 1 billion. You put 1 billion inside here. You can using calculator and calculate, key in everything in your calculator. When you divide these two numbers, even though it's infinity over infinity, the value is around, because this one is like insignificant. 3 times infinity here is not bigger than this one. This one is infinity cube, is very large number. So only these two will determine the values of this function, right? It's like very rich people here, right? This one become insignificant here. So when you divide the ratio of x cubed, this is 3 times compared to this one. So 3 over 2. That's why you're getting 3 over 2, right? Because this x cubed, they were getting the same value. They were getting the same value here. The very big value, but have the same value. When you divide, you're getting 1. So that's why you take 3 over 2. So you're getting 3 over 2 here. Because the value behind here is insignificant compared to this one. This one is too large. It can absorb anything smaller. So okay, so I will giving you another video. It's also about this type of cases, infinity or infinity, so that you have more understand better.